Yes, I did remember to put a red circle around it because it's kind of difficult to see. He calls this the pale blue dot. That's us. We're the pale blue dot. We're like a tiny little lifeboat floating in space. There's nowhere else to go. This is planet A. There is no planet B. We need to take care of this thing because if it doesn't, our lifeboat sinks and we are sunk. So that's by way of an introduction. And my little subtitle in red up there is Risk Management for Your Grandchildren's World. So that's the message I want you to take away. Okay, you now become my apostles to go out into the wide world and tell your family and your friends and your colleagues, if you're still working, and your local politicians the message. Okay, next slide, please. What's going on? Well, you can actually educate yourself quite easily without becoming a scientist like me, because there is ample information around. There are two covers of two books here. On the left, this is by Tony Juniper. Tony Juniper used to be the guy who ran the Friends of the Earth, and he now writes about planetary things. So the title is What's Really Happening to Our Planet. It's a wonderful thing to read. It's full of colored pictures and little tables showing you what's happening. It's designed for people like yourselves. It's not designed for scientists like me, but I love it because I can tell people all about it. And on the right, you recognize that young lady? Yes, this is Greta Thunberg. I think she's now 17. But she started her school strikes when she was 15. Every Friday, she'd go and sit outside the school with a placard saying, you know, we must save the planet. That's her recent book. Can't read the title. A Year to Change the World. Yes, thank you. A Year to Change the World. Can I have the next one? Right, and here are three other books. I call these the three wise men. We're going to get to the wise woman later on, but these are the three wise men. So on the left, there's good old Sir David Attenborough, and he just made a film late last year, A Perfect Planet. I hope some of you saw that. It's a wonderful little film. But along with that, he produced this book, A Life on Our Planet. And it sort of distills all that Attenborough stuff that he's been doing for donkey's years. I think he's, now 96 or something like that. It's a fabulous book because it's written in language that all of us can understand about what's happening to the planet and what we should be doing to stop this getting worse, or even to remediate things and improve matters. In the middle, this guy, Mark Carney, does that name ring a bell? Yeah, former chairman of the Bank of England, a Canadian, but a guy who was sort of imported in and did a grand job, but he finished in 2020, and then he sat down and wrote this book. It's called Values. Well, what we have been talking about this morning, and what we are talking about, is our values. What are our values in relation to the Earth? You know, do we value the Earth? Do we want to be the masters and exploit it? Do we want to be stewards of it because we value it and we want it to last for our children? It's a very interesting book. Some of it's about economics, some of it's about philosophy, some of it's about what are we doing, but really educational. And the third one is by this guy, Bill Gates. Now, I suspect that most of you know who Bill Gates is. If you've got a computer, this is Mr. Microsoft. And, but he's a technocrat. And what technocrats do is they really like technological solutions. And what he's done is he's pouring money, well, you probably know he's pouring money into Africa to get mosquito nets for children, so that they can sort of stop malaria in its tracks. But this is about how to avoid this coming climate disaster. It's not a disaster yet, but it could be if we don't do something starting right now. And so he lists the kind of things that are now feasible, the things that can now be done, the things that he would like you to lobby your government, our government, to do on our behalf and on the world's behalf. So you can educate yourself. You can find out about this stuff. And these books are not difficult to read. They are not textbooks. They are meant for publication. Next one. Right, so what is it all about then? The first thing it's about is numbers, population. Now, when I can see that some of you in the audience are about my sort of age, I'm 79. Any others that era? One or two? Okay, numbers. So there were 7.5 billion, no, there were 2.5 billion people on the planet when I was a child in 1950. Now there are 7.5, so it's gone up by a factor of 3, and we're heading for a population of about 9.5 billion by 2050. So all those extra people, we're adding as many people to the planet as there were on the planet when Bridget and I were children. It's an amazing thought, isn't it? Lots of extra people. What will they need? Energy. They all want more energy. Where are they going to get it? Do we want them to be burning fossil fuels? Probably not, because that's what damages the environment. And if you damage the environment, who do you damage? Yourself. So there's a real link. We are all interconnected. So people, that's one problem. And we're not going to get rid of the people. I'm going to talk about population in a moment. But we have to recognize that they will need to use energy to survive and to do things. The second one is reckless consumption. Nico's already alluded to that this morning. Using up our finite resources. Now, as I said earlier, we're on planet A. There is no planet B. We have to think carefully about how we exploit the resources we have. And then the final one is the global impact. And there are two factors there that I'm going to touch on today. One is global warming. We are burning fossil fuels, which puts greenhouse gases into the atmosphere. Those gases absorb heat that's coming off the Earth, and they warm the atmosphere. And so ideally what we want to do is to stop burning fossil fuels so we don't put those gases into the atmosphere. And the other one, the other important one, is deforestation, the loss of biodiversity by chopping down forests, by farming more intensively, all the things that we do. Our biodiversity is decreasing quite significantly. I think this morning we've already mentioned the Amazon forests and the Congo forests. We might also have mentioned Indonesia, where things get chopped down to make teak furniture so that you can have it in your gardens. Next one, please. Right, so this is a graph showing the decline in the numbers of live births to women globally. This is a sort of statistic produced by an organization I used to work for. It's UNESCO, the United Nations Education, Scientific and Cultural Organization, which is based in a horrible city, Paris. Yes, I know. It was actually a lovely place to be. But what you see here is a big decline. Now, going back to the left-hand side, 1950, what we have is 4.7 live births per woman. And that has declined with time. It's now slightly under 2.5. That's a really very significant drop in the numbers of children that women are having. In Europe, I think our overall numbers of children born are less than 2, which means we're just below replacement value. In Japan, it's down to about 1.5, which is well below replacement value. In Africa, the numbers are still high, but they're dropping all the time because what UNESCO has been doing is a massive program in educating women and girls about reproduction and about having children, and do they really need to have 6 children? I mean, the reason that people in these environments used to have a lot of children was because they didn't have any pension funds, and their pension fund was their children. You know, when they got to be old, it was those 6 children that were going to keep providing the food they needed just to stay alive. Life's not like that anymore, and so people are feeling the need to have fewer children. This means that that's why there is going to be less population pressure on the planet after about 1950, because these numbers are dropping. The blue line ends in 2017, and the projections of the 2 orange lines take us down to close to 2, which is just just renewal rate. But by 2050, the curves should start to turn the other way. The overall population's curve should start to go down, which will eventually lead us to need less energy for all those people. Next slide, please. Right, this is the curve going in the other direction. This is our temperature going up. So on the left is 1850. Yes. And on the right is 2020. So what you're seeing there in the red line is the annual variation in temperature. And you can see it was bouncing around until 1900, which is sort of the third of the way along from the left-hand side. And then it starts to tick up. It goes through a peak, which you see in the middle there. That's 1940. Then it drops off and flattens off a bit. And then from 1970, you see that steep upward deflection with the blue line running through it. That's what's been happening since about 1970. Our climate has been seriously warming, and where we were last year is that little star at the top right labeled 2020. The dashed green line across there is 1 degree above what it was in 1900. So we take all the stuff on the left-hand side from 1850 to 1900. That's the background, what we call the pre-industrial temperature, before we really got to be a highly industrialized global civilization. And so things have been really increasing. Now, when I say that the global average temperature is now, you can see from that, is 1.2, in the Arctic, it's double that. So it's 2.4. Okay? Where's the ice? In the Arctic and the Antarctic. But I'm going to focus on the Arctic. Greenland, the Greenland ice cap, permafrost in Siberia, all of that is going to start melting. Well, it already has started melting because the Arctic temperature is about 2.4. So that's what we have to watch out for. You may not feel much temperature rise here in the UK. We are protected, in a sense, from all of these changes because we're surrounded by the ocean, which brings a sort of ameliorating effect, a cooling effect. If you lived out more in the eastern side of Europe, you would find it much hotter. If you lived in the Mediterranean, you'd find it's getting much hotter. So, as I say, we're a little bit protected from that. But this is where the problems are lurking. Next one, please. And this is the reason. This is the amount of carbon dioxide going into the air in millions of metric tons. That's millions of metric tons. That's the figures down the left-hand side. What you see is on the it goes from 1850 again, the same as the temperature thing. At the bottom in orange is coal. So we started out in the 1850s just burning coal, and that slowly increased. The red line down the middle is 1950. You can see how even coal burning started to increase more after 1950. That's partly because of our growing population. The green is oil, which we started to use around about 1910, small amounts. And then you see that started to grow just a little bit. 1950, it really shot up. Now we burn huge amounts of oil for our transportation system mainly. And then you see the purpley color is natural gas. That's methane. You might know that as marsh gas. It's what you cook with in your kitchen if you've got a gas stove. And you can see how that has increased also tremendously. And finally, the funny one is cement manufacture. That's a little blue line at the top. When you make cement, you take limestone and you heat it. And when you heat it, it drives off carbon dioxide. So even making cement, we're actually putting carbon dioxide into the atmosphere. Carbon dioxide is a greenhouse gas that warms the planet. So we can see here the direct linkage in these two slides, this one and the previous one. We're burning fossil fuels. We ramped up that in 1950. The temperatures started to go up. From 1970, they've been rocketing up. And that's because of the emissions of carbon dioxide into the atmosphere. Next one, please. Right, so I want to, I just love Antarctica. You know, I've got my penguin badge here around my neck. I think it's the same one I wore the last time I was talking to you. Right, so just ignore the graphs on the right for a minute and look at the little picture on the left. And what you see is Antarctica with the ice on it. It's a cross-section. great big thick mass of ice on the left-hand side, and it wants to slide away. It wants to slide down into the ocean, and so it does. The little blue arrows show it sliding down to the right, and it slides out over the ocean and gives you what we see as these big flat shelves of ice. And they're about 800 meters thick, and they go up and down with the tides, and at the outer ends become unstable, and bits fall off, and we call those icebergs, like the thing that sank the Titanic. What is happening now is that with global warming, heat is going into the ocean, and that warmer water is now creeping up underneath these ice shelves, represented by the red line there. You see the brown is the submerged land under the sea, and the warm water is coming up over that surface, creeping up under the ice shelves and actually melting them from underneath. That makes them move faster, and that helps them to drag more ice down from the interior. And it's when you take the ice from the interior and you put it in the ocean, the sea level goes up. The sea level also goes up for a second reason, which is that when you warm water, it expands. So you've got this double whammy hitting the ocean, the melting of ice on land and the warming of the ocean itself. At the top right-hand side, you see these graphs with the purplish color heading down to the right. So there we're going from 1980 on the left, that's the vertical green line on the left, to 2010 is the green line on the right, and we're going past that to the present. And what I want you to focus on is the purple line. So the purple line represents the total loss. So you can see from, if we take 0 at 1980, then there's been an enormous decline down to the right in Antarctica, which is the box at the top. And if we go to the box below that, that's Greenland. And we look at the purple line, and we see, again, starting from about 0 in 1980, where the vertical green line is, that also goes way down to the right and crosses the 2010 green line to the bottom. Now, the amounts involved here are in very large numbers, gigatons. A gigaton is 1 billion tons. Can you imagine 1 billion tons? How many African elephants would that be, I wonder? Probably more than there are in Africa. How many London buses would make 1 billion tons? Probably a lot more than there are buses in London. So these are enormous amounts. And both of them, if you could see the detail down the left-hand side of the little graphs there, they're telling us that each of these places has lost 5,000 gigatons. That's 5,000 billion tons. So add that together, 10,000 billion tons of ice lost from Greenland and Antarctica to help raise the sea level. So no wonder it's going up. Next one, please. So this is a graph that shows you the actual sea level rise since about 1990. So on the left-hand side is a scale in millimeters. So if you divide that by 10, you get centimeters. So from 1993, the colors represent a series of satellites, one after the other, all making the same measurements. But satellites don't tend to last all that long. You have to replace them. So there's a sequence of satellites in the orange one, the blue one, the yellow one, and the green one. But what you can see is there is a slight up curve to this line. It's not a perfectly straight line. I got a ruler and I drew a straight line from 1993 through the data on the left-hand side of the chart, and it continues out through the right-hand side of the chart. You can see the gray line. And you can see that the satellite data is actually, after about the year 2005, is starting to diverge from my straight line. So what we were hoping to see was a straight line, but the actual sea level has accelerated. And now it's a good 20 millimeters more than we might have expected in 2020. So this tells us that we really do have a problem. We're burning far too much fossil fuel we're burning far too much fossil fuel, which is putting far too much carbon dioxide into the atmosphere, which is warming us, as we saw from the first graph, much too fast, and that is leading to the sea level going up too fast. Next one, please. And what we see in this picture is the uneven distribution of heat around the world. Now, the colors in red are all warming. The colors in dark red are more than 2 degrees. The colors in blue are where it's cooling. So what you see is that this is the difference between the warming in the 2000s from the warming in the 1990s. So it's the difference in those 2 decades. And so what we see is there is an enormous amount of warming across the Arctic, and that's where the icy stuff is. And that's why the ice is melting in the north. Now, if you look at the rest of the diagram, you can see there are some red patches like the Arabian Peninsula. You can see some red patches in California. So there are some places where the warming is well above normal that are not in the Arctic. But most of the places, you get the sort of pale brown color, which tells you, yes, there's some warming, but it's not all that much. The UK is a sort of pale orange, so it's not warming as much as the Arctic. You can even see some places there which are pale blue, which means they're actually cooling rather than warming. And right in the middle of the Pacific, you see a dark blue blob. So there was a period in time between those 2 decades when the Pacific actually cooled down. So this global warming stuff isn't uniform. It depends on what's happening in the different regions. And so we scientists have to work out what the averages are for the world as a whole and then for the different regions in order to try and understand what's going on so that we can make appropriate recommendations to governments. But the message is that the Arctic in particular is warming. Now, why is that important? The sea is covered in the winter by sea ice. Literally, the surface of the sea freezes. Doesn't do anything to sea level, just freezes, and then in summer it unfreezes. And the thing about all that white, flat surface is it's highly reflective. It reflects the sun's energy, and that's what helps to keep the Arctic cold. If you take away that flat, white surface, you lose that reflection, so the Earth gains heat. And that's one thing we're doing to the Arctic. Okay, we're taking the mirror away that reflects the sun's energy, and so it's warming more. The second thing is that when you take away that white surface, what you get exposed is dark-colored sea. And dark colors, as you probably know, absorb heat. And so what you have is a double whammy. You've lost the mirror that reflected the sun's energy, and you've gained something that really absorbs it, which is the ocean. So it's really warming up fast, and that explains, even though the Arctic is not a place where you'd expect it to get warm, is it really? You know, that's where the Greenland ice sheet is. So it's a kind of a surprise. It's kind of a, counterintuitive that it's warming twice as fast as the rest of the planet. But this is one of the consequences of global warming. That's why we're worried about it, because we're worried about the melting of the ice, which, as I just showed you, is accelerating. If we keep the warmth in the planet, even at the rate that it's warming now, into the future, then that ice is going to melt more and more and more, and the sea level is going to go up just about everywhere. Next one. This is in Siberia. Now, Siberia, as you can imagine, is really cold. It's so cold that the groundwater beneath the surface freezes. And so we call that permafrost. It's permanently frozen ground. And it's not the dirt in the ground that's frozen, it's the water between the particles of dirt. Okay, and that permafrost can be 1.5 kilometers thick. In the summer season, the very surface can melt and then refreeze. But now, because of global warming, even Siberia is warming up. Last year, Siberia had a record temperature of 38 degrees centigrade. That's more than we had. That's amazing for such a place. And what's happening is that large chunks of the surface are melting away. A whole green space there, that's the tundra, which is sitting on top of the permafrost, so permanently frozen ground. And this crater here is a kilometer long and it's 90 meters deep. It's enormous. And what you see in the whitish stuff that's the frozen ground that is still waiting to melt, but everything around it has already melted. And if you were close enough, you could probably see down at the bottom right-hand corner a little, the bluey color of a little stream that's taking the melt water away. So even in places like Siberia, we're seeing these dramatic changes that are consequences of global warming. Next one, please. Right, so fires, floods, seems strange to have the two things in the same sentence, but our September last year was the world's hottest ever September, globally. 2019, that was Europe's warmest year ever. Siberia, heat wave in 2020, reached 38 degrees. And you probably saw on your telly, right, the wildfires in Australia. Remember those? Terrible, you know, all those poor koala bears are being burned. And so we got wildfires in California and Australia. These are naturally dry places, but because of the extra heat from the global warming, it was easier to create these very large fires that were impossible to control. However, although you can get more drying in dry areas, which leads to fires, in areas like ours, you get wetter, because you know, Britain is a fairly wet country. You get rain because it's a little island surrounded by the ocean. There's lots of water sucked up into clouds, and what happens? It gets dumped on the land. And so the warmer climates suck up more moisture from the ocean in your warmer climate, so you evaporate more moisture from the ocean. It gets into the air, the winds take it over land and dump it on us. So it turns out that when you do that, you get more floods. And I think we've all read the newspapers last year. Flooding was really bad in some areas. And it turns out that in the UK, we had our wettest day ever on record since records began about 1650. And that was on October the 3rd last year. And similarly in Germany and France and Italy, they had similar consequences. So we see these consequences of global warming, of fires in one place, floods in another. Next one, please. Right. So I wanted also to talk about the other things that we're doing to the planet, not just about global warming. And one of the things we do is we build dams. We put dams across rivers. They create lakes we can use for agriculture. The dams can be used for hydroelectric power. You know, it's wonderful stuff. So on the left, top left is 1900. The next one over. No, 1850. Right, so it's 1850, top left, 1900, 1950, and 2000. Isn't that amazing? You know, virtually the whole United States is now covered with dams. Every single stream or river that they've got has got at least one dam on it, and probably up to 5 or 6. And this is a picture that's repeated around the world. We have dammed things all over the place because we wanted to exploit the environment, okay? Now, dams do two things. First of all, they can slow the amount of water getting to the sea. You may be familiar with the fact there's a river in the US called the Colorado River, yeah? And it drains down through, from Colorado, right down through Southern California into northernmost Mexico, into a gulf called the Gulf of California. The Mexicans get almost no water now. It's all used en route by American farmers. The Nile is very similar. I'm sure you've heard of the Aswan Dam. Okay, they dammed Aswan. They had to actually dig up some of those ancient pharaonic monuments and move them so that we could still see them once the dam was created. So that was for agricultural purposes. What you probably don't know, and I didn't know until I went there in 1976, is that the Nile is also dammed at the mouth. So almost every drop of rain that falls anywhere on Egypt is now trapped in the Aswan Dam and downstream by the dams at the mouth. It's all used for agriculture. But what this does is it stops the rivers carrying silt to the sea. You know, the rivers used to carry silt and sand down to the sea. They built deltas. You all know what a delta is. A delta is that shape. It's a Greek letter delta. And those, over time, more and more sediment got dumped on them, and eventually they started to sink. So deltas are places where you want the supply to keep coming in so that you can balance by growing the sediment pile on top. You can balance what's being taken away from you by subsidence, by the huge weight of the delta actually causing the earth underneath to subside. Okay? So that's what's happening. Now you can imagine what this means when you think about sea level rise, okay? The sea level is going up. We just looked at the sea level rise graph. And the Nile, the delta's going down. Where's the sediment supply to balance that? Stuck behind the Aswan Dam. And so by creating all these wonderful dams, which helps our agriculture, we are actually meddling with the whole interface between land and the ocean, which is damaging the deltas. So that's another problem for us. And here is another aspect of the way in which we're changing the planet. On the left is a picture of what used to be an Indonesian rainforest. And now, I'm sure you can all see, there are regularly spaced little dots. Those are palm oil plants. Palm oil plants, it's a palm that gives lots of oil. We use it in all sorts of products. I think it's in ice cream, it's in popcorn, it's in all sorts of, you know, funny product. You wouldn't expect to see it, but it's an oil that's quite useful. But it means we've had to destroy the rainforest in order to get that. And on the right, you see a world map with brown areas on it. Those brown areas are where we have used the soils so much that the only way we can get them to grow anything is by dumping huge amounts of fertilizer on them. So this is another way in which we're interfering with the natural world. And it turns out, if you look at the map, you can see that the brown area, you've got brown areas and darkish blue areas, and then pale grey areas like the Amazon or Greenland. Altogether, we are now using, for agricultural or living, 75% of the planetary surface, the land planetary surface. Only 25% is still wild land. And so the question is, what are we actually doing to those surfaces? Are we over-exploiting them? Next slide. Okay, so one of the messages I have is it's not simply a question of climate change. We're also interfering with the biodiversity, which was the point of the last slide. And there is this linkage between biodiversity, that's biodiversity means how many organisms are living on the planet. What's the ecosystem like? You know, this is all tied into things like damaging the Amazon rainforest. Now, you may not realize this, but globally we farm, not just we Brits, but globally, 5 billion hectares. And of that, 4 billion, that's 80%, is for meat and dairy. I bet you didn't know that. You probably think it's all wheat fields and rice fields. Not at all. Not at all. And now, a lot of that land that's farmed for meat and dairy is not just for the animals as rangeland, it's also for growing soy products, because one of the things in the US they do is they keep cattle not in fields, they keep them in feedlots, where they feed them things like soy products to fatten them up. Not the nicest way of treating animals. But it turns out that of all our farmland, 60% goes for beef cattle. And all they produce from that 60% of farmland is 2% of the calories we need. Do you think that's a good balance? Use 60% of your farmland to produce 2% of your calories? Doesn't really make a lot of sense. It doesn't fit with this word sustainable that we're hearing a lot about lately. Now, the other thing about all these animals is that they produce gases, waste gases, from either end. And those gases consist of methane, which we've already talked about, carbon dioxide, and also nitrous oxide. That's the N2O there. And so what scientists have done studying animals is they've worked out how much all the animals produce, and cattle produce 1.9 million tons of these gases per year. Sheep and goats produce just 0.3 million tons per year. Billion. Pigs produce 0.2, and poultry a measly 0.05. So which animals are contributing most to the problem of having carbon dioxide in the atmosphere? It's cows and beef cattle. So we do need to think very carefully about what we eat. I'm not telling you shouldn't eat meat, because quite clearly some of these animals are not producing very much at all. So if we wanted to keep eating meat, it would be better to eat chicken or bacon or lamb than eating beef. Besides, my wife discovered that there are a very nice Beyond Meat hamburgers that you can eat in the finest restaurants, and believe you me, they taste just like meat. Next one. Right, so Bridget asked me to talk about plastics, and so I will. On the top right, you see a typical picture of a beach. I don't think it was an English beach. Must be some foreign beach, you know. Can't trust these foreigners, can you? And then in the middle, on the left, is a picture 1,000 meters down off the coast of Spain. And what you see with all those funny wiggly lines, those are discarded fishing nets from trawlers. And so just about everywhere you go in the ocean, whether it's on the beach or deep in the sea, you find discarded plastic waste. And what happens to most of that waste? Well, when it gets into the ocean, it's picked up by the major currents. Now, the black arrows around the yellow and orange dots show you the way in which the big ocean gyres are working, right? So they go around one way in the northern hemisphere and they go anti-clockwise in the southern hemisphere. But what happens is when the plastic gets washed into those areas, the currents concentrate them in the middle. So in the Pacific one, that orange blob is the Great Pacific Garbage Patch. It's the largest accumulation of oceanic plastic rubbish in the world. And mostly it's fairly big stuff that's easy for the winds and currents to move around. And they're trying to get out there with ships towing big nets behind them that can trap this stuff and put it in a barge and then take it away and store it somewhere on land rather than leaving it in the ocean. So the orange and the yellow is where our plastic garbage tends to be concentrated at sea. Next slide. Yeah, we also produce microplastics. So what you're looking at here on the left-hand side, in the picture on the left-hand side, is synthetic fibers that are about 5 to 6 to 10 millimeters long. The little scale bar there is, I'll just check. Yeah, the little black scale bar is 1 millimeter long. And so these plastic fibers, you find them everywhere. They are plastic, and one of the things they come from is washing your fleece. Every time you wash a fleece, about 100,000 tiny little plastic particles go down the plug hole. And they get out, they get washed out, they go through the sewage system, and they end up in the ocean. And the other thing that we used to do, but hopefully we don't any longer do that, not in this country anyway, you see those products in the tubes up at the top right-hand side. Those were sort of cleaning products, and they contained within them little tiny plastic balls, so that when you rub them on your skin, it will rub off the dead skin cells. And so those little glass containers that you see in front of these plastic tubes, those are the amounts of little plastic bubbles that were in those tubes. So some of them contained a lot more than others. But again, once you washed it off, it went down the tubes and got into the ocean. And fish and birds and plankton thought it was food. And so you get fish now, you find dead seabirds now. You'll find lots of this microplastics actually stuck inside them. In fact, some of it may have gotten into you if you've been eating fish lately. So, we have a problem. It's the things that we do that contribute to where this plastic's going. I know the government is very keen to cut down on plastic waste, and I was listening to the radio while I was driving here. Our Environment Minister, who's, I think it's Rebecca somebody, was explaining that the government is about to introduce an environment bill in September which will, get more to grips with how we treat the environment. Good. Next one. Right, so this is the amount of plastic that's being produced. So the graph shows you the amounts in millions of tons up the left-hand side are going from 1950 across the right. You can see that the production of plastics has been increasing very considerably over time. So by the time we got to about 2015, it was about 200 million tons per year. And if you added all that together, you begin to get to close to 1 billion tons of plastics produced. And if you converted all that plastic that we've produced globally into that sort of kitchen wrap, it's a very thin kitchen wrap that we all tend to use, you could actually wrap the planet. There's that much that we've been produced. And most of it ends up in waste in landfill. Next one. So what we're looking at here is the production of two other things. One is aluminium, and the other one is concrete. So on the left you see the amount of aluminium produced in millions of tons. That's the red line, and you can see how after 1950 it really shot up. And on the right-hand side is the amount of concrete we've been producing, but that's in billions of tons. So 500 billion tons of concrete, 500 million tons of aluminium. These are new products that we really weren't dealing with much before 1950. I mean, I know the Romans had concrete, but there weren't many of them. And they left here anyway and went back to Italy. So we now produce enough of this stuff to actually carpet the planet. We're producing as much of this stuff as nature moves. When nature moves sediments in rivers and glaciers, nature is moving the same amount as we are moving by creating concrete. Next one. Okay, so here you see we've now produced enough aluminium foil to completely coat the United States. In President Trump's era, that might have been quite appealing. Now that we have President Biden, perhaps it might not be such a good idea. And on the right, that's a city. Build cities. What are you using? Glass, steel, and concrete. And so we've now produced enough concrete to cover the world with 1 kilogram per square meter, which is an awful lot of concrete. So this is one of the ways, these are some of the ways in which we're changing the planet. Next one. Right, so geologists now consider that we've changed things so much, we've now become the equivalent of a geological force, taking all humans together, a geological force operating on the surface of the planet. We're changing the air, we're changing the ice, we're changing the water, we're changing the land surface in all these different ways. So in a sense, we have created, as I say, a rupture in the functioning of the planet. Since 1950, you've seen all these things zipping up since 1950, and we're all healthy. We have a wonderful National Health Service, we've got wonderful medicines that are helping us to survive and live longer, but at the same time, we're not doing a favor to the planet. But the planet is our life support system. So the question is, are we damaging our life support system? Next one. Right, there's another way in which we're changing things. This may not have occurred to you, but we transport plants around. When you go to Richmond Park or something, one of the things you might go to is, I think this is the Elizabeth section. It's full of rhododendrons and azaleas. They're not British, They all came from somewhere else. India or Japan. We Brits are very good at this, We went all the way to New Zealand. That's about as far away as you can get. And what do you see when you go to New Zealand? You see almost as many, as you see there, 1,570 introduced plants for the 1,790 or odd plants that are natural. So all these places like Hawaii, California, New Zealand, We, in moving around the world, have moved plants. And plants have also been moved here. You know, I bet a large number of the plants in your gardens aren't British. They're probably not even European. This is what we do to the planet. We've mixed and merged and changed the ecology. Next one. Here's another consequence. This is how ships move around. So you can imagine a ship from Canada takes a lot of whatever it's manufactured locally out to Russia or the Ukraine, and it drops them off and people buy them, and then there's nothing to bring back. So what they do is, to load the ship, they suck in water for ballast. It's just called ballast water, very imaginative, but it contains the larvae of the organisms that live in those environments. And when it gets back to the Great Lakes area, what does it do? In order to bring its new cargo on, it has to get rid of the ballast water. So all those larvae from Russia and Ukraine or wherever get into the water supply, and one of those creatures is the zebra mussel. That's a picture of it down there. And the dark purple, dark brownish color shows you where that zebra mussel has spread. And it's a terrible thing. It kills off the local mussels and things that used to live in the water, and it blocks pipes, it blocks rivers, it blocks streams. It's a real environmental hazard, which is part of our global trade system. So this is another way in which we have to be very careful what we're doing. I do a lot of work in Antarctica. These days, if you go down to Antarctica, they will take your bag from you and they'll vacuum the interior and all the pockets, and with your boots, they'll wash your boots in disinfected water with disinfectant in it, and to make sure you, when you get off the ship and go onto the shore in Antarctica, are not taking anything with you that could contaminate the environment. So this is another kind of problem that we are doing to the planet. Next one. Okay, this, just briefly, the upward curves, we're going from the 1500s on the left right up to the present on the right. And basically, all you need to see is that the blue and the red and the green and the orange curves are all tilting upwards. That's because we are losing species. We're losing mammal species, bird species, insect species, reptiles. And the red writing at the bottom says that mammals, birds, fish and reptile populations, that's globally, have fallen by 60% since 1970. This is from the WWF. They really ought to know what they're talking about. So this is another way in which the things that we're doing to the planet without caring for it, without being stewards, but instead being masters, this is the result. Next one. Okay, so you see 4 little diagrams up at the top. On the right is a picture of a mammoth, and the size of the box gives you the impression of how much mammal wildlife there was on the planet before humans came along. The little box next to that with a picture of an elephant in it shows you that today's wildlife, that's elephants and lions and tigers and all that, represents about a quarter of what wildlife used to be. And on the left, we see the size of the box with the human in it, and that is something like at least double and probably almost 3 times the box containing the mammoth. And further on the left is the box representing the size of our domesticated animals. It's vastly different to the way it used to be before humans came on the scene. And so this is another way in which we are changing the surface of the planet. There are an awful lot of us. We have an awful lot of domesticated animals. And the list down here shows you, for example, yes, there are lots of wolves on the planet, 200,000, but we have 400 million dogs. And there are something like 40,000 lions, not as many as there used to be. But compare that, we've got 600 million cats. Does anybody wonder why our bird population is decreasing? We have 900,000 African buffaloes. That sounds like a lot, doesn't it? But in comparison, we have 1.5 billion cows. And for those 50 million penguins, you balance that out against 20 billion chickens. So you've got 50 million against billions. And early man obviously killed off a lot of the wildlife that we used to have. But, you know, we have changed the way the planet works. Next one. And I think this is close to final. We would like to see that forest, for example, up in the north, places like Norway or Canada and so on, were nice and healthy, like those fir trees on the left-hand side. And in fact, one of the positive things about putting carbon dioxide into the atmosphere from burning fossil fuels is it is a plant food, and so plants tend to grow faster with a bit more carbon dioxide in the atmosphere. The problem is that along with the carbon dioxide, which is the food, goes the warming. And it turns out that that changes the way that insects reproduce. So on the right-hand side, this is a modern Canadian forest, and it's affected by the pine bark beetle. The pine bark beetle used to only be able to reproduce once per year. Now, because of global warming, it reproduces twice per year, and so it's reproducing now faster than the forest can manage to actually combat it. And so what we're seeing is forests being destroyed by the changes that we have wrought. Okay, next one. Right, so the UN is very concerned about this. The UN in 2015 created something called the Sustainable Development Goals, and it wants to persuade governments around the world to achieve these by 2030, which is not very far away, just 9 years away. And you see some of these goals, you can follow this up on the web. If you just Google UN Sustainable Development Goals, you'll come up with this chart. And if you click on any one of these, a whole list of things will come up as to what they want to do, what they want us to do to get there. So the first one is very desirable, you know, eliminating poverty. Well, we'd all agree with that, wouldn't we? But I don't want to go through the whole lot. I'm just going to focus on the ones with the red hearts on. So we've got things like, you know, controlling emissions, having safe, sustainable places to live in, and then down at the bottom corner, the green one, number 13, is controlling the climate so that it doesn't get out of hand, and then the blue one is controlling life in the ocean so we don't lose all of our fish, and the green one next to that is controlling biology on land so that we don't cause our forests to collapse. Next one. Right, so now we get to the wise woman. This lady is Kate Raworth, and she is a professor of economics at Oxford University, but she wrote this really interesting book, Donut Economics, written for people like you and I. I mean, I'm not an economist, so I need somebody like her to hold my hand and walk me through this stuff. And so the net result is that there in green is her donut, and on it there are two dark rings. The inner ring is what we need to do with our social spaces, have better education, have more care for the elderly in the community, all sorts of good stuff like that, you know, warm and fuzzy stuff. But the outer ring is what concerns me as a scientist. That's how we are treating the ecology. She calls it the ecological limit. And so what you see here, there are 4 red areas where we have gone beyond the ecological limit. One at the top is climate change. The one at the bottom right is the way in which we've loaded the land with artificial fertilizers, nitrates and phosphates, in an indiscriminate way. You know, farmers were encouraged by companies like Monsanto to liberally spread nitrate and fertilizer over the land. And what happened when it rained? It all washed off and went into the ocean. And then what that did was it created huge blooms of plankton, which sucked all the oxygen out of the air, out of the water, and gave us what we call dead zones when no fish could survive. So that's a big problem in certain areas like the Baltic Sea, for example. So what she's trying to point us to is we don't have to change everything, but we need to really get a grip on some of these areas where we have too much nitrate fertilizers, on climate change. There are things that we can do to control these, and that's, in other words, we don't have to focus on every darn thing. We need to focus on certain areas where we can make a difference. And if you want to read a bit more about her, and you don't want to read her whole book, she has a very nice article published in The Lancet, the British Medical Association journal, in 2017. But yeah, even though you're members of the public, if you Google Kate Raworth, Donut Economics, The Lancet, 2017, it will come up with this. I think it's a 2-page article. Very well worth reading. Next one. Okay, so are we making progress? Yes. The International Energy Agency says that wind and solar are now the cheapest forms of energy, much cheaper than fossil fuels. In the UK, we now realize that solar and wind energy is a heck of a lot cheaper than we thought it was going to be. In the first quarter of last year, renewable energies supplied 47% of all of our energy requirements, and by Boxing Day, more than 50% came from just wind alone. So, you know, we are making good progress. The UK has actually, by doing this, lowered its carbon emissions by a huge amount, by 40% since 1990, and we're planning to go even further. Companies like BP and Shell are actually saying that they want to go green to actually get more involved, less involved in fossil fuels and more involved with renewable energies. But there's a challenge for us. That's a challenge for you and me, people like us in this room, because 48% of the UK's emissions of carbon dioxide come from our households, our household use of energy, our failure to insulate our homes, and from our use of transport, particularly cars, especially SUVs, which emit 25% more carbon dioxide into the atmosphere than other cars. So we need to get a grip. You know, this isn't just about the government. I know there was this nice little phrase in here about we want to pray for our government, should have the vision, understanding, wisdom, and integrity to see what actions are needed, and the skill, imagination, and energy to implement them. But it's up to us as well, you know, as individuals, not just the government. We are doing things. The UK is going to stop the sale of petrol and diesel cars, new cars, from, when I wrote this it said 2030, but I think they've now brought that forward to 2025. In Norway, already 54% of new cars were electric last year. Next one. And this graph shows you in the UK, you probably can't see the detail, but the scale on the left in the top graph goes up to 500,000, and I think, let me see. Yes, on the left it's 2012, so almost none in 2012, and then you can see the numbers climbing until we've got almost 500,000 in 2020. So we are gradually going electric with our cars. The pale blue colours are for battery vehicles only, and the darker blues are for hybrids. I'm feeling very virtuous today because I have just bought a hybrid. My first. Now, down at the bottom, what we see is where are the charging points that you, as an electric car driver, can use to charge your battery on your journey? Obviously, that's a very important question. And so what we see is, again, from 2012, we can see a rise in the number of charging points. And the government is actually determined to foster the development, foster the purchase of these electric cars by providing you with the charging points. It's obviously easier if you've got a driveway that you can park your car on, because you can then plug into your house to get to draw electricity overnight. But in my area, I have on-street parking, which is not so good. So where am I going to get electrical energy for a battery-operated car? Difficult. I might have to drive down to Waitrose, where they have, I think, 2 charging points. We need more of these things if we want people to change their habits. Next one. Right, now here's a change. You might have seen this in last year. This was September 2020, the UK's first ever hydrogen-powered train. Amazing. And pretty soon that will develop into commercial services. This is a sort of development phase. Already in Austria, they have hydrogen-powered trains. We will have hydrogen-powered trains soon, coming onto different lines. And so that's another change, another way of not burning fossil fuels. although you still have to have electricity to create the hydrogen. Next one. Right, so there is hope. Now, the message I want you to take away is, yes, a lot of this change is about the government, and you should not be afraid of the government. You're a voter. Your vote counts. You need to vote for parties that are going to do something about the environment. And the one way you can ensure that happens is by contacting your MP. Get in touch with your MP. Talk to them, write to them, go and visit them in their surgery. Make sure they understand that you are a really concerned individual and you want them to do something. But also make a list of what it is you want them to do. And they will then take that message forward to Parliament. So what do you want them to do? You want to demand change. You want to demand, we need more research and development into the new technologies like battery technology and so on to enable us to get into this electric future rather than a fossil fuel future. Ideally, if this will require some subsidies. Right now, it's the oil companies that get subsidies. We need to change that around and make sure that the new green industries get a lift-off, a boost to enable them to fly. We need better infrastructure for our solar and wind and also nuclear power. Nuclear power these days is much, much safer than oil or gas or coal. And so it is something we should be using more of. You can influence the market. I've already talked about plant-based burgers. You can get those instead of meat. You can, if you've got an SUV, get rid of it, because they're 25% more polluting in terms of carbon production. If you can, buy a hybrid or a fully electric car. You can switch your electricity supplier. There are plenty of electricity suppliers these days that are green, that use solar and wind only. You can reduce at home. You can be sure that your house is not leaking heat to the environment. If it is, then you're contributing to putting more carbon dioxide into the atmosphere. So try and make sure your home is heat tight. One of the ways in which you can actually better use power is to introduce a heat pump into your garden. Anybody here got a heat pump? Okay. Is that an air heat pump or an in-ground? Air. Is it noisy? No. Oh, that's good. Okay. I have heard people say that air heat pumps can be noisy and irritate the neighbours. Very good. Okay. I've got a friend who lives in Scotland who has quadruple glazing, a heat pump underground in his garden, a conservatory with lots of glazing, complete insulation, and he doesn't pay any money for heating his house. So he's in Scotland, just outside St Andrews, and so, you know, he doesn't have any energy bills at all. That's in Scotland, because he's taken all those, you know, all those things into consideration. And then finally, pension fund. What's your pension fund like? Do you actually know what your pension fund investors are doing with your money? Do you know are they investing in non-fossil fuel stocks? Find out. You may not like it, what you find, but you can tell them what you want them to invest in. And then finally, recycling is very important. Because we don't recycle enough, we have to exploit more resources. So one of Kate Raworth's message, the wise woman, is make sure you recycle everything. Make sure your council recycles everything. That's another thing to demand. Get onto the council. Make sure that they're working with local companies to recycle everything. Otherwise, we've got to keep finding more stuff to dig up, which it doesn't make sense if you want to live sustainably on the planet. So there you have it. Last slide. That's my message. And I hope you found it interesting. I hope you can take it away, and I hope you can do something with it, because action is what's important. We all have the ability to act. So now it's over to you. Get some action. Yes, yes.
Not one of these new build houses has got solar panels on the roof. Why not? That surely should be something we should be going on about. And the second question, it's not frivolous. Where do vegetarians get all their soybeans from? I think some of the deforestation in the Amazon is for vegetarian burgers as well.
Okay, that was two questions. One is, why don't new builds have solar panels? A very good idea. I mean, I could say, why don't all the houses I walk past in Guildford have solar panels on? You know, I mean, people have known for donkey's years about this problem, but the number of solar panels is actually rather limited. I suspect it's down to two things, education and money. Now, when David Cameron first came into power, I think he and George Osborne had a scheme where you got a subsidy if you put solar panels on. Then they quickly ripped that away. And so I think people were taking advantage of it and then stopped. So the message is, if you want people to do things, you have to incentivize them. And so I think incentives are needed so that people with current houses will put solar panels on. But also, I find it really odd. You know, this is the left hand of government doesn't know what the right hand is doing. So you've got the Department of Housing encouraging developers to build houses, and the Department of Environment wanting us all to go green, but they're not actually talking to each other in cabinet. It's insane. But that's government for you. Then your other question was, okay, vegetarians eat lots of soybeans. I'm largely vegetarian, so I guess, you know, guilty. Where do the soybeans come from? Yes, I actually don't know the answer to that question. I should find out. Can you put the penultimate one back? There it is. There you go. Can we just leave that up there for a while? If anybody wants to take a photograph of it, please do.
In 2020, China opened the equivalent of one large coal-fired power station a week. This is more than 3 times new coal plant capacity as the rest of the world. Does this not make our efforts, commendable though they be, ineffective? Should we not be putting more pressure on China to conform, and in your opinion, in what way?
Yes, so in China they are building a lot of coal-fired power stations, and so China is now the major emitter of carbon dioxide from coal. However, the major emitter in carbon dioxide per head is still the United States by a long streak. China comes next. So China per head is still producing a lot. Actually, I think the top one's US, then there's Australia, and then there's Canada, and then there's China. And one thing we have to remember about China, I will answer your question, but one thing we need to remember about China is we offshored our manufacturing industry starting in 1980 with deregulation. The United States did the same under Reagan. And where did a lot of that industry go? It went to China. So it turns out that 30% of what the Chinese are doing is our manufacturing for us. And so 30% of their emissions is actually ours, and it should appear on our balance sheet. And so they are burning coal for us. So it's not a pretty picture when you think about it. In China, the government is trying to cut down things because they have already said they want to get to zero carbon by 2050. So, they're pushing in the right direction. They have a problem within China that the local, out in the boonies, the locals know that they've got to produce more power, and so they are tending to build quickly coal-fired power stations, which the government actually doesn't want them to do. So there's a real problem within China about communication about what to do, but the government is now beginning to clamp down on that. So I'm sure that in the fairly near future we will see the number of coal-fired power stations in China quite radically reduced so that the Chinese government can meet its international obligations. I hope that satisfied your question. Sorry, the last bit lost me.
How can we as a country be more effective in pushing pressure? Should we lobby our MPs?
Oh, you mean about China? Yeah, that's already happening. In November this year, the UK government hosts the international meeting of the UN Framework Convention on Climate Change. It's in Glasgow. And all of these countries will be represented there. And so already the UK is leaning very heavily on all the member states that are going to come to that meeting to make sure that when they come with their, what they're going to put on the table is their declared commitments of what they're going to do to get down to zero by 2050. And so already the UK is leaning on China to come along with the appropriate package at that meeting. So later this year we will have a much better idea of what all governments around the world are intending to do so that we can actually get these carbon dioxide levels down. And China is just one of the multitude that will be there. The UK is cracking the whip on this. Okay, so the question is, if Greenland is melting, and presumably other icy areas melting too, what's that going to do to our sea level, and how much land are we going to lose, basically? Yes. So we know from geology, by looking back into the past, that there were times when it was warmer naturally than it is now, and we know that at those times the sea level was significantly higher by about 10 meters. So 10 meters, that's 33 feet. And it would not be good for us if around our coast the sea level was 33 feet higher. For one thing, that would overtop the Thames barrier, so Londoners wouldn't be too happy. So there is a lot of awareness around about what the impacts will be if we allow sea level to go on rising. And so all countries are aware of this, and the scientists are making their politicians aware of this so that the right decisions get made and the right policies get made so that we don't go there. We don't actually warm as much as we have examples of from the distant past. Right now, it's difficult to say exactly how our coast will be affected. What I do know is that the east coast of the United States is probably going to have higher levels than the average for various local reasons than us. And in places like Scandinavia, where there was an ice sheet depressing the land down in the last ice age, once that ice was removed, the land started to come up. So in Scandinavia, in southern Sweden, for example, the sea level is falling because the land is coming up. And the same applies to northern Canada. You may have heard of Hudson Bay. Hudson Bay was the center of the major North American ice sheet. And once that ice sheet went, Hudson Bay started to come up. And so you can see the current bay is very much smaller than the original one, and so the current bay is surrounded by bathtub rings of where the water once was, but because the land's going up, Hudson Bay is actually shrinking. So we have to bear all those things in mind to get at an average sea level rise, and the average becomes kind of meaningless when you talk about the individual areas because they're each behaving in a slightly different way. I hope I answered your question. Yeah, I don't want to see a 10-meter sea level rise.
Sorry, everybody, but I think you better stop if you don't mind. Thank you so much for that wonderful talk. We've had a wonderful morning with you, and lots of nice questions, and we'd like to applaud. Thank you very much.
Well, that was enlightening and disturbing in equal measures. Thank you so much, Dr. Summerhayes, for giving us a real insight into what we should be doing and into what our grandchildren, and I worry our great-grandchildren, might expect the future unfolds. This is the first time we're managing to get together as a national organisation, and what a wonderful way to open up. The service was thoughtful and hopeful, just as our Christian faith ought to be. The singing was simply beautiful, and it would be great to put Reverend Nico's address on our website, please. Is he still here? Yeah. I want to pay particular thanks to Epsom, who've been organising this event for months, it seems, and have had to cope with numerous setbacks on the way. I want to especially praise Bridget Chorner, who's chaired the Founders Meeting Committee and her group, namely Sue King, Deanna Gannon, Edith Hakin, Colette Topman, Marilyn Cameron and Anne Broad. Anne did the printing. Thank you, Anne. Marilyn? Bridget, would you come up, please? Oh! Thank you very much from all of us. I know also you all also want to give a huge vote of thanks to Anne Constable, our national events organiser, who over the year has nimbly changed plans, altered dates and sorted out internet interaction, and has always been there for committees and venues. She's not here, as you know, but is watching from afar. Anne, thank you. Finally, I want to wish everyone well, especially those who are here, including 9 other branches. Then there are potentially 100 members from all over the country linked in online. This has been a real treat. Thank you. Now I want to hand over to Frances, who's just joined the committee, the executive committee. She's going to tell you about Founders Meeting next year. COVID-free. Let's hope.
This is the commercial break. Shrewsbury branch of Women in Fellowship is looking forward to welcoming members to Founders Meeting 2022, get your diaries out, on Wednesday the 25th of May 2022. The theme chosen for the first post-pandemic Founders Meeting is healing, and the branch have invited David Knott, author of the autobiographical book War Doctor, to speak after lunch. The theme will also be reflected in the preceding service, at which Salopian Reverend Canon Mark Oakley, Dean of St John's College, Cambridge, has been invited to preach. The event will be held in Shropshire at Netley Hall, Netley, Dorrington, a 19th century Grade II listed hall set in beautiful grounds. It's to be found some 6 miles from the centre of Shrewsbury. Members are welcome to travel up the day before and join Shrewsbury members for supper, with overnight accommodation provided by Shrewsbury members or in local hotels. It is possible to stay at Netley Hall itself or in cottages in the grounds of the hall. Although our branch name is that of the county town, our members come from all over Shropshire, a beautiful but little-known county, which, notwithstanding that, has given the world the first skyscraper. Not sure about that after our last talk. The sweet pea and the modern Olympic Games. Shropshire is well worth exploring, so come for Founders Meeting and stay on for a few days more. I look forward to seeing you in 2022, and the letter is signed in fellowship, Mary Rose Bone, the chairman of the Shrewsbury branch of Women in Fellowship.